Question 1. In the context of installing a split-system air conditioner in a multi-story commercial building, Mr. Alvarez needs to mount the indoor air handler on a ceiling-mounted bracket in a mechanical room adjacent to an occupied office space. Vibration noise is a concern, and local codes require service, accessibility, and proper condensate drainage. Which of the following best practices should Mr. Alvarez prioritize to ensure compliance and performance? A. Secure the unit directly to steel trusses with rigid anchors to minimize deflection. B. Use vibration isolators, ensure 36-inch service clearance, and slope the condensate drain at 1/8 per foot. C. Suspend the air handler with chains to allow for movement and avoid vibration transmission. D. Elevate the unit on cinder blocks to prevent contact with ceiling materials and avoid noise issues. Answer. Correct answer. B. Explanation. Point 307. Condensate drains must be properly sloped to avoid standing water. ASHRAE Standard 62.1 recommends vibration isolators to prevent structure-borne noise. Mechanical codes require service clearance of at least 3.036 inches depending on equipment. Rigid anchors A. Amplify vibration. Chains C. May allow excessive sway. Cinder blocks D. Are not approved mounting supports. Question 2. When analyzing the requirements for handling refrigerants during system installation, which of the following actions best aligns with EPA Section 608 regulations and best practices for minimizing environmental harm? A. Venting R400 TINA outdoors during system evacuation since it's non-ozone depleting. B. Reclaiming refrigerant into a certified recovery cylinder prior to disconnecting old equipment. C. Using a standard nitrogen purge to remove all residual refrigerant before system recovery. D. Capturing refrigerant into a recovery bag and labeling it for disposal. Answer. Correct answer. B. Explanation. Under EPA Section 608, venting any refrigerant is prohibited, including HFCS like R400 TINA. Only certified recovery cylinders, not bags, are acceptable for refrigerant recovery. Nitrogen purges are used after recovery, not before. Violating this can incur fines up to $44,539 per day per violation. Question 3. Given the circumstances of installing a rooftop HVAC unit, Istran is routing high-voltage wiring from a disconnect switch to the compressor terminal block. The conduit path includes exposure to weather and potential foot traffic from maintenance staff. What NEC-compliant and safety-conscious approach should she take to ensure proper installation? A. Use flexible metal conduit for the entire length to allow for easier maintenance. B. Each conductors exposed across the rooftop to minimize conduit cost. C. Install PVC conduit with watertight fittings and secured to rooftop supports. D. Use intermediate metal conduit with weatherproof fittings and maintain support every 10 feet. Answer. Correct answer. D. Explanation. NEC 344 allows IMC for exposed outdoor use, requiring supports every 10 feet. It withstands physical damage and UV exposure better than PVC. Flexible conduit A is only allowed in short lengths. The exposure B is prohibited. PVC C can degrade under UV and thermal cycling. Question 4. To better understand air properties, what change will occur to the dew point temperature in an HVAC system if the relative humidity is increased while dry bulb temperature remains constant? A. Dew point will remain unchanged. B. Dew point will decrease. C. Dew point will increase. D. Dew point and dry bulb will equalize. Answer. Correct answer. C. Explanation. An increase in relative humidity at a fixed dry bulb temperature means the air is holding more moisture, thus increasing the dew point temperature. This is shown clearly on the psychrometric chart. Dew point only stays constant. AERH isn't changed. Equalization D only occurs at 100%. Question 5. As illustrated by a scenario in which Mr. Jefferson finishes installing a heat pump system during winter, ambient temperature 38 degrees, he must charge the system with refrigerant. What is the most appropriate method to ensure accurate charging under these conditions? A. Charge by superheat using outdoor air temperature as reference. B. Charge by subcooling with manufacturer's target and use indoor airflow measurement. C. Use fixed pressure temperature chart to add refrigerant until pressures match. D. Postpone charging until warmer temperatures are available. Answer. Correct answer. B. Explanation. Charging in cold conditions requires subcooling method with manufacturer-specified targets, especially for TXB-equipped systems. Indoor airflow must be verified, usually 400 CFM per ton. Superheat that applies to fixed orifice systems. PT charts C are insufficient alone. Delaying D isn't practical or necessary. Question 6. Through the lens of energy efficiency, how does a poorly sealed building envelope affect the performance and sizing of an HVAC system during installation? A. It requires smaller capacity systems due to increased natural ventilation. B. It leads to oversized systems that cycle frequently and perform poorly. C. It does not affect the system as load calculations consider window size only. D. It improves indoor air quality due to uncontrolled air exchange. Answer. Correct answer. B. Explanation. A leaky building envelope increases heating and cooling loads, often prompting contractors to oversize equipment. This results in short cycling, higher humidity, and inefficiency. Manual J calculations account for insulation, envelope orientation, etc., not just windows. Uncontrolled exchange D worsens IAC due to unfiltered air. Question 7. When evaluating the merits of nitrogen purging during the brazing of copper refrigerant lines, what is the primary reason it is recommended as part of best installation practices? A. It prevents line expansion due to high internal pressures. B. It avoids formation of copper oxide scale inside the tubing. C. It seals the system from external leaks after brazing. D. It accelerates the brazing process by raising the oxygen concentration. Answer. Correct answer. B. Explanation. Nitrogen purging displaces oxygen, preventing formation of oxidation scale inside copper tubing, which can cause metering devices and damage compressors. This is considered best practice under ASES and ARI guidelines. It doesn't seal the system C or alter internal pressure significantly. Question 8. Mr. Chen installs a multi-stage thermostat for a dual-stage furnace, but notices the staging does not function during testing. Given a proper wiring layout, what is the likely cause if both urinals are connected but second-stage heat doesn't engage? A. The thermostat is set to single-stage mode in configuration settings. B. The WMNL must be jumped to its staging to occur. C. The control board needs a delay timer added externally. D. The thermostat wire gauge is too small to transmit staging signals. Answer. Correct answer. A. Explanation. Many advanced thermostats have configuration menus requiring manual setup for multi-stage operation. If set to single-stage, engage even if wired. Jump in. B. Defeats staging logic. Delay timers. C. Are internal. Wire gauge. D. Affects voltage drop but not staging directly. Question 9. Based on the information in a system design blueprint, a return duct branch crosses above a hot water pipe in an attic. What is the most appropriate corrective action during fabrication to prevent performance loss due to heat gain? A. Install the duct as designed and increase blow speed to compensate. B. Relocate the return duct branch below the hot water line to avoid direct contact. C. Insulate the return duct with R8 insulation and add a radiant barrier above. D. Replace the metal duct with flexible duct for better temperature resistance. Answer. Correct answer. C. Explanation. Per icon ASHRAE 90.1, return ducts in unconditioned spaces must be insulated, minimum R8. Adding a radiant barrier reduces radiative heat gain, increasing blower speed. A. Causes noise inefficiency. Flexible duct. D. Is less durable and more prone to damage in attics. Question 10. While examining a newly installed HVAC system, Romero notes poor cooling performance and high superheat readings. The TSSV appears functional and airflow is verified. What is the most likely issue based on the symptoms? A. Overcharged refrigerant. B. Restricted liquid line dryer. C. Failed condenser fan. D. Incorrect thermostat set point. Answer. Correct answer. B. Explanation. A restricted liquid line dryer limits refrigerant flow, causing starvation at the evaporator and high superheat. Overcharging A. Causes low superheat. A failed fan, C, leads to high head pressure. Thermostat settings, D, don't affect system refrigerant dynamics unless calling is incorrect. Question 11. Throughout the course of commissioning a newly installed variable air volume valve system in a commercial space, Mr. Dorsey observes that the zones are maintaining temperature set points, but the supply fan is running at constant high speed and energy consumption is abnormally high. What is the most likely installation issue that should be addressed first? A. Incorrect installation of bypass dampers causing high static pressure. B. Oversized compressor operating at full load under partial demand. C. Variable frequency drive, VFD, not receiving proper feedback from pressure sensors. D. Improper zoning layout resulting in overlapping thermostat control. Answer. Correct answer. C. Explanation. VFDs rely on feedback from duct static pressure sensors to modulate fan speed. If the sensor is not wired or configured properly, the fan runs at full speed, wasting energy. Bypass dampers are used in older systems. Compressor oversizing. B. Affects refrigeration, not airflow. Zoning. D. Impacts control, but not fan operation directly. Question 12. When evaluating the startup amperage of a newly installed scroll compressor is to Quan records no array operator amperage value that briefly spikes above the nameplate rating but quickly stabilizes. What does this observation indicate about the electrical integrity and system setup? A. The contactor is undersized and may burn out under full load. B. The circuit breaker is incorrectly sized for continuous duty. C. This is a normal startup behavior and indicates proper function. D. The system is short cycling due to low refrigerant charge. Answer. Correct answer. C. Explanation. Scroll compressors often exhibit a Briouret spike at startup, which is normal and accounted for in breaker sizing per NEC Article 440.22. It's not sign of contactor A or circuit breaker issues. B. Short cycling. D. Results in frequent stops, not one-time amperage spike. Question 13. Under the assumption that refrigerant piping for a mini-split system needs to be routed across a roof and down an exterior wall, which of the following practices will ensure the piping installation complies with both mechanical code and manufacturer guidelines? A. Use soft-drawn copper, support every 8 feet, and insulate only the suction line. B. Use hard-drawn copper, provide proper slope, insulate both lines, and have protect insulation. C. Use flexible refrigerant lines, route through existing electrical conduit, and leave ends open during pull. D. Use pre-charged line sets with flare connections, supported only at elevation changes. Answer. Correct answer. B. Explanation. Hard-drawn copper is recommended for exposed runs due to rigidity. Per IMC section 603 and manufacturer guidelines, both suction and liquid lines must be insulated and UV protection. E. G. Covering or paint is essential. Supporting lines every 810 feet is required. Routing through electrical conduit. C. Violates electrical separation. Question 14. In light of recent developments in code enforcement, an inspector rejects a new gas furnace installation due to lack of combustion air intake. Which requirement did the installer most likely overlook? A. IMP requirement for sealed return ducting. B. NFPA 70 requirement for bonded metallic piping. C. HRConquer or IMP provisions for combustion air from outdoors or ventilated space. D. ASHRAE 90.1 minimum efficiency rating for gas-fired appliances. Answer. Correct answer. C. Explanation. IMC 701 and ERE Chapter 24 require adequate combustion air to support gas appliance operation. Without this, negative pressure can cause backdrafting. Return duct sealing A and pipe bonding B are unrelated. Efficiency D is important but not cause for combustion air rejection. Question 15. A demonstrated by a situation where Price uses a digital vacuum gauge while pulling a vacuum on a newly installed heat pump. She notices the micron reading stalls at 1500 microns. What is the most appropriate step to take next to achieve an acceptable deep vacuum? A. Inject nitrogen to clear moisture, then restart vacuum process. B. Add refrigerant to pressurize and force out non-condensables. C. Replace the vacuum pump oil and continue evacuation. D. Open the system valves to equalize pressure between sections. Answer. Correct answer A. Explanation. Triple evacuation with nitrogen helps displace moisture or contaminants. Moisture can stall the vacuum progress. Adding refrigerant B is illegal if done before evacuation. Replacing oil C is useful, but only if oil is contaminated. Opening valves D defeats the evacuation. Question 16. Given the circumstances of a homeowner asking about uneven temperatures between floors after HVAC system installation, what is the most professional and technically accurate response the installer should provide? A. Suggest closing registers upstairs to redirect airflow downstairs. B. Recommend zoning or balancing dampers to control airflow by floor. C. Explain that temperature variance is normal and not fixable post-install. D. Advise adjusting the thermostat set point every few hours manually. Answer. Correct answer. B. Explanation. Balancing dampers or zoning systems help manage airflow across different levels, especially when temperature differences are common. Closing registers A increases static pressure and reduces efficiency. Manual adjustments D are inconvenient. Dismissing the concern C reduces customer trust. Question 17. During the process of inspecting a system with poor cooling and constant compressor operation, Mr. Ellison notices frost on the suction line and low evaporator pressure. The blower motor is operating normally. Which component is most likely at fault? A. Compressor is overworking due to incorrect voltage supply. B. Condenser fan motor is stuck, reducing heat rejection. C. TXB or metering device is underfeeding refrigerant to evaporator. D. Blower relay is stuck, running continuously. Answer. Correct answer. C. Explanation. A frosted suction line and low evaporator pressure typically indicate underfeeding by the TSB, possibly due to a clogged filter or bulb malfunction. The blower D is working. Condenser fan B would cause high pressure. Voltage issues A usually trip safeties or affect compressor startup. Question 18. A fundamental question is, when a refrigerant changes state from a vapor to a liquid in the condenser, what thermodynamic process is primarily taking place and why is it essential for HVAC performance? A. Sensible heat rejection. It removes heat from refrigerant via direct temperature drop. B. Latent heat rejection. It allows condensation without changing temperature. C. Compression. Increasing refrigerant pressure to reduce its volume. D. Expansion. Lowering refrigerant pressure to enable evaporation. Answer. Correct answer. B. Explanation. Condensation is a latent heat process where vapor becomes liquid without temperature change, releasing stored heat into the environment. This is critical for heat rejection in the refrigeration cycle. Sensible heat involves temperature change. Compression and expansion occur elsewhere. Question 19. While examining a residential system installation, Mr. Benton identifies long flexible duct runs in a crawl space with noticeable sagging between support straps. What is the most immediate concern regarding this installation approach? A. The duct is not sufficiently insulated against moisture. B. Sagging causes dust to accumulate in low points. C. Air velocity drops due to increased friction and static pressure. D. Rodents can enter through the unsupported sections. Answer. Correct answer. C. Explanation. Sagging ducts increase friction loss, disrupt laminar airflow, and reduce system efficiency. Per SMACNA guidelines, flexible ducts must be supported every 4 feet and pulled taut. Dust accumulation B is secondary. Insulation A and rodents D are valid concerns, but airflow is the immediate impact. Question 20. Among the various methods of determining appropriate system size, which best reflects compliance with industry standards and ensures proper comfort, energy efficiency, and equipment longevity? A. Basing system size on square footage and comparing with neighboring homes. B. Using utility bills and homeowner complaints to determine equipment capacity. C. Conducting a manual J-load calculation that accounts for all heat gains losses. D. Installing the largest unit within the homeowner's budget for better coverage. Answer. Correct answer. C. Explanation. Manual J-load calculations per ACAS standards provide a precise assessment of heat loss gain based on orientation, insulation, window type, occupancy, and more. Square footage J is not accurate. Budget-based sizing D leads to short cycling and humidity issues. Question 21. While commissioning a rooftop package unit, Delgado notices that the economizer is opening during peak cooling demand even though outdoor air temperature is above the set point. Which of the following is the most likely cause? A. Damaged damper actuator causing uncontrolled outdoor air intake. B. Faulty mixed air temperature sensor calibration. C. Compressor contactor welded in closed position. D. Low refrigerant charge causing coil icing. Answer. Correct answer. B. Explanation. A miscalibrated mixed air sensor can falsely indicate a cooler temperature, causing the economizer to open even when outdoor air is too hot. Damper actuators A. Cause mechanical issues but not wrong decisions. Contactor issues C. Affect compressor control. Coil icing D. Is unrelated to economizer logic. Question 22. During a commercial kitchen HVAC inspection, the airflow from the makeup air unit is insufficient to balance the exhaust hood. Which adjustment is most appropriate to address the issue? A. Increase the return air damper position. B. Increase supply fan speed or adjust VFD to meet design CFM. C. Close nearby diffusers to redirect more air to the kitchen. D. Reduce exhaust hood CFR until balance is achieved. Answer. Correct answer. B. Explanation. Makeup air must match exhaust flow to maintain neutral or slightly negative pressure. Adjusting the fan or VFD. B is correct. Changing return air A won't solve it. Closing diffusers. C disrupts other zones. Reducing exhaust CFM. D compromises ventilation requirements. Question 23. The technician is retrofitting a system from R22 to R407. Which procedure is mandatory before charging the new refrigerant? A. Recover old refrigerant, replace oil with PO, and replace filter dryer. B. Add R407 on top of remaining R22 to save time. C. Recover old refrigerant, leave mineral oil in place and top off. D. Replace compressor to match new refrigerant compatibility. Answer. Correct answer. A. Explanation. R407 requires PO and the filter dryer must be replaced to prevent contamination. Mixing refrigerants B, C is illegal under EPA rules. Compressor replacement D isn't always required unless incompatible. Question 24. In a chilled water loop, the delta T between supply and return is significantly lower than design. Which condition is most likely causing this? A. Air trapped in the expansion tank. B. Low water flow due to throttle balancing valves. C. High water flow rate through coils. D. Undersized chiller capacity. Answer. Correct answer. C. Explanation. High flow rate reduces heat transfer time, lowering delta T. Low flow B would increase delta T. Air in expansion tank A affects system pressure, not delta T directly. Undersized chillers D cause temperature rise, not drop. Question 25. A heat pump in heating mode is running continuously but delivering lukewarm air. Outdoor ambient temperature is mild, which is the most probable cause. A. Reversing valve stuck in cooling position. B. Defrost board locked in test mode. C. Low refrigerant charge causing low coil temperature. D. Auxiliary heat strips not energized. Answer. Correct answer. D. Explanation. With mild temps, the heat pump should supply warm air, but without auxiliary heat strips, supply temperature can be inadequate during demand spikes. A stuck reversing valve A would produce cold air. Defrost board issues B cause intermittent heat loss. Low charge C usually results in frosting and lower capacity. Question 26. When analyzing a psychrometric chart for a large office building, Mr. Landry notices that the return air has a dry bulb temperature of 75 degrees and relative humidity of 60%. If the goal is to lower humidity without overcooling, which approach is most appropriate? A. Reheat air after dehumidification using hot water coil. B. Reduce airflow to allow coil to drop temperature further. C. Increase outdoor air ventilation to dilute indoor humidity. D. Install larger evaporator coil for increased latent capacity. Answer. Correct answer A. Explanation. Dehumidification occurs by cooling air below its dew point to remove moisture, then reheating to avoid overcooling. A. Reducing airflow. B. Risks coil freezing, increasing outdoor air C. Can worsen humidity if ambient or HSI. Oversizing evaporators. D. Can cause short cycling and poor humidity control. Question 27. During installation of a new condensing unit is Whittaker measures a single-phase compressor motor drawing high current but failing to start. The start capacitor tests within spec. Which next step is most logical? A. Replace the run capacitor. B. Test the potential relay for proper operation. C. Replace the compressor contactor. D. Bypass the overload protector to see if the motor starts. Answer. Correct answer. B. Explanation. A faulty potential relay can prevent the start capacitor from being removed from the circuit, causing startup failure. Replacing run capacitor A is unnecessary if it tests good. Contactor replacement. C. Won't solve starting torque issues. Bypassing overload. D. Is unsafe and violates NEC safety protocols. Question 20. While commissioning a residential HVAC system, Mr. Santos finds that certain rooms have significantly less airflow than design values. Static pressure readings show excessive positive pressure in the supply plenum. What is the most probable cause? A. Undersized return ductwork causing airflow restriction. B. Improperly balanced dampers in branch ducts. C. Faulty blower motor winding reducing speed. D. Clogged evaporator coil restricting airflow. Answer. Correct answer. B. Explanation. Excessive supply plenum pressure with uneven distribution usually points to damper imbalance. B. Undersized returns. A. Affect system-wide airflow, not individual branches. Motor faults. C. Would reduce total airflow. Clogged coils. D. Restrict both supply and return evenly. Question 29. Histokim is brazing copper lines for a split system installation. The nitrogen purge is set too low, causing incomplete protection inside the tubing. What is the most likely consequence? A. Excessive oxidation inside tubing leading to contamination. B. Increased joint porosity causing refrigerant leaks. C. Warping of copper tubing from overheating. D. Immediate blockage from molten flux residue. Answer. Correct answer. A. Explanation. Without adequate nitrogen purge, oxidation flakes form inside tubing, later clogging SSVS or filter dryers. Joint porosity. B is usually from poor technique. Warping. C is heat-related, not purge-related. Flux residue blockage. D applies to soldering, not brazing. Question 30. During a service call, is Harper finds a heat pump short cycling every 3 minutes in cooling mode. Pressures and superheats of cooling readings are normal. Which of the following is the most probable cause? A. Defective thermostat or improper cycle rate setting. B. Blocked condenser coil reducing heat rejection. C. Refrigerant leak causing low suction pressure. D. Oversized indoor evaporator coil increasing latent load. Answer. Correct answer. A. Explanation. Normal pressures and refrigerant readings indicate the mechanical system is fine. A thermostat fault or settings A can cause short cycling. Blocked coils B and leaks. C. Alter pressures. Oversized evaporators D affect humidity control but not cycling time directly.